Hi, in this Let's Create episode, we're going to create a simple block stacking game like this. The blocks spawn at the top, you have to press space to drop them, and you need to try and get as many on the platform as you can. Let's get started. I'm going to start with a Unity 2D project template called Block Tower. The first thing I'm going to add is the base. So I'll create a 2D square sprite and rename it base. As we're in 2D, we've got an orthographic camera which defaults to 5 units. So we'll put this at y equals -4, so it's near the bottom, and set the x scale to 5 and the y scale to 0.1. That creates a nice thin base for us. Let's make it a nice ground grey colour, and then we can add a box collider 2D to it so the blocks will land on it. For the blocks, we'll create another 2D square sprite. We'll leave the size for this as it is. To this, we'll add the box collider 2D and the rigid body 2D. We don't want the block to fall until we tell it we're ready, so we'll uncheck the simulated box for now. I'll set the collision detection to continuous. As this is such a simple game, we can afford the extra complexity of that. Create a prefab directory and drop this in there. I'm going to rename that to block for clarity. We can delete the original from our scene now. Create a scripts directory and a new C# script called Game Manager. This is where we're going to do most of the game logic. Add an empty game object to the scene and attach the Game Manager. Now we're ready to dive into some code. First up, we're going to need some references to objects. The first is the block prefab, which we're going to use to spawn our new blocks. We're going to be moving this about, so we'll get a reference to the transform of it. The second is a block holder object. This is just so we can spawn our blocks within an object rather than cluttering up the scene. At the start of the game, the first thing we'll want to do is spawn a new block. So we'll create a new method for this. We use instantiate to create the block prefab, passing in the block holder as the parent. We'll assign this into a current block global, as we want to refer to this later. Then we'll want to set its start position. So let's create a new variable for this called block start position and set it to y equals 4 so it's near the top. To make the game a bit more interesting, we'll assign each block a random colour. We get a reference to the sprite renderer component and change the colour to be a random one. When we interact, we'll want to enable the simulation on the block. So we add a new variable for that called current rigid body, and we'll get the associated component from our new block. Finally, to make the game more interesting, every time we get a new block, we want it to get harder. So we'll add 2 new variables, block speed, which is how fast the block is currently moving, which we'll set to 8, and block speed increment, which is how much faster it'll get after each block is spawned. Then in our spawn new block method, we can just increase the block speed by block speed increment. Now let's deal with the block movement. In the update method, if there is a current block set, i.e. we've just spawned one, then we calculate how much it needs to move this frame by taking the time.delta time, which is the time elapsed since last frame, multiplying this by our block speed, and we want to move it back and forwards, so we need to know which direction we're going in. We'll add a block direction variable, setting it to 1 to start with, and then we can include this in our move amount calculation. We set this to -1 when we want it to go in the other direction. Next, update the current block position by increasing the x value of the position by our move amount. We need to know when the block is to reverse direction, so we'll add an x limit variable and set that to 5. As the width of the base was 5, that'll mean the block extends over the edge to make the game more interesting. So we check when the position is greater than this, and we use abs here because we're essentially checking if x is greater than 5, i.e. it's gone to the right, or if x is less than 5, it's gone to the left. If it is, we set the position to this limit, just to stop it going too far, then we reverse the block direction by negating it. This will change 1 to -1 and vice versa. Excellent. The only thing remaining now before we can test it is a way to release the block. So we'll do this just by checking if the user presses a key with get key down, and I've chosen space. When that happens, we set the current block to null. This has the effect that the if statement in the update loop will no longer be called, so the horizontal motion will stop. Then, using our reference to the rigid body, we enable the simulation so gravity will take effect and the block should fall towards our base. Finally, we want to spawn another block so we can do this all over again. So call spawn block. Let's check that out. So back in Unity, we need to create an empty game object to be our block holder. Then, to the game manager script, we add references to the block prefab and the block holder. Hit play and check it out. Pressing space makes the block fall. As we progress, the blocks are moving faster, making it harder, and they're different colours. This is all looking great. The only minor change we should make now is that when we drop a block, it should wait before giving us the next one. So back in the code, we'll create a new coroutine called delayed spawn. First we'll use wait for seconds to pause, and we'll create a new variable for this called time between rounds, which I'll just set to 1. Then we call our spawn new block method. In the update function, we can then just replace the spawn new block call with the start coroutine call and pass in our delayed spawn. Let's try that out again. This is looking much better. We now want to add the logic so that we can detect when blocks fall off so we lose a life, and we can end the game when we're out of lives. First we'll add a UI text element called numLives, so we can display the number of lives. As Unity now uses TextMeshPro by default, we get the pop-up where we can import the TextMeshPro essentials to get the fonts. If for some reason this hasn't happened for you, we can do that manually by going to Window, TextMeshPro, Import TextMeshPro Essentials, and importing that. Press Ctrl F to focus on the selected elements. Let's pin the text to the top right by holding Alt to snap it there, and then let's pull it away slightly and center the text in the box so it looks good. Focusing back on the main area, we'll duplicate our base and call it Fail Collider, for want of a better name. Move it down off the screen and expand the X scale so it's wide enough to catch everything. We can disable the sprite render on this because we don't actually need it to be drawn. Finally, we'll set isTrigger on the box collider as we just want to tell when a block passes through rather than actually interacting with it. Create a new script called loseLife in the scripts directory and attach it to this new object. This is a very simple script. We'll need a reference to our game manager and then create an onTriggerEnter2D method. This will be called every time a block enters the collider. Here we can simply call the removeLife method in our game manager. That's it. We'll now jump over to the game manager script and add in these last bits. To start off, we'll add a reference to our TextMeshPro to display our lives text in. Then we'll add 3 more variables. Starting lives will be how many lives we have to start with, and we'll set that to 3. Lives remaining will hold our current count, and we'll have a boolean called playing, which is initially set to true, to indicate if the game is going or if we've ended. First up, in our start method, we'll set the lives remaining to starting lives, and make sure our text box shows the right number of lives. In the update method, we'll add an extra condition to our if statement to include the playing boolean, as we don't want to keep spawning things once we've hit the game over state. Whilst we are here, we'll also add an extra key, in this case escape, which we'll use to restart the game by reloading the scene. Really, we should have a button we surface to do this, but I'll leave that up to you. Finally, we need to add our extra function removeLife, which is called when things fall off the platform. This simply reduces the number of remaining lives. We cap this with a max statement so we don't go negative if a lot of blocks fall off at once. Then we update the text showing our lives. If the number of lives hits 0, we set playing to false, which stops anything happening in our update loop, which essentially ends the game. So back in Unity, on our fail collider, we'll add in a reference to the game manager, and also in the game manager, we need to add a reference to the TextMeshPro numLives text so we can update that. And we should be good to go. So let's try it out. Now we can have fun with this very simple but actually quite difficult game. When our lives run out, the game stops, and then we can press escape to reload the scene and start again. As ever with these Let's Create series, I've provided you with the bare bones of a game, and there are lots of ways you can adapt it to make it better. I hope you found this tutorial useful in some way. As ever, the code is on GitHub and linked in the description below. If you have any requests for the Let's Create series, please let me know in the comments. See you next time.